Hello, everybody. Welcome to Houdini Hangout. This is the 9th of February. My name's Peter. Welcome to the stream. Thanks for joining us. Sorry for the harsh cut there. Was not expecting that. I had my thing set improperly, but you know what? The show will go on. Yeah, so we were talking about Solaris a little bit last time, talking about specifically working with USD rather than maybe some of the flashier parts of, the Solaris tool set. We were talking about how we can actually work with the kind of with the low level USD that's happening, kind of under the hood in Solaris. So, we're going to be continuing that conversation today, get into some other topics and ideas, talk a little bit about maybe how we bring USD files from disk into our scene, how we organize it, kind of organizing our scene so that things get saved in different sections. That's kind of a big part of USD, is that files can kind of lay on top of each other. They can layer on top of each other and create details that can kind of reference things that came in the file before. So it's a very interesting way of working, as far as it's really different than a lot of other file formats that you'll run into out there. It's not like an Alembic or an FBX or anything like that. It really is such a unique way of working, and I think if you are interested in this kind of thing, this is going to be something that starts to hopefully give you some sense of how you could use this in your workflow, whether you're on your own as an individual or if you're in a studio. It doesn't really matter. I think all of these features and techniques are super valid as far as what you could do with USD when you're working in Solaris. So so like I said, we're going to be touching on a few topics today that are going to be somewhat technical, but also I hope really helpful for you, even though they might be this might be a little bit more dry topic than we've had in the past. I know we've gone through all the Vex stuff, so hopefully this will be a similar but different kind of vein as far as the part of Houdini that we'll be working in. So what we're going to do first, before we start really working with USD, is we're going to actually just build ourselves some little asset that we can kind of look at and figure out how to what exactly we want to, how we can bring that into our scene. So that'll be step one, and then we'll kind of go from there, use some files on disk that we made last stream, and also look at the merge lop. I know that might be a crazy thing to look at, but it's really different than the merge SOP. And so understanding how that works, I think, is really important for Solaris, because there's some options in there that could do some really crazy things that you wouldn't be expecting it to. So hopefully we'll kind of demystify that a little bit and make some sense out of that. Sorry, let me bring that over here. You don't even see that. I am just checking something real quick here to make sure this is good. Looks good. Cool. All right, great. Well, let's jump into some Houdini, and we'll get going here. All right. Oh, the other thing I should say before we get started, a couple things. First of all, apparently there's some crazy windstorm happening tonight in my area. So if I was to lose power or something, just if I disappear all of a sudden, sorry. What can you do? Second, please, if you have comments, if you have thoughts, if you have questions, or if you think I'm doing something really wrong and you'd like to add your 2 cents, please feel free to drop your comments in the chat. I would love to hear them. I'm always interested to, this is as much for me as it is for you as far as learning goes. I'm going to try to talk through some stuff here, but if you have questions, or if I'm not explaining something well, or, whatever, these are all situations for all of us to learn. So please feel free to put your questions in the chat, or comments after the video. No question is too out there or too silly to bring up, because if you're having the thought or the question, probably someone else is as well. So I always welcome that, and welcome corrections or whatever, because I'm not the the expert in Houdini. I do love using it and love learning about it, but we're always learning, and we're always kind of trying to expand our knowledge. So please feel free to correct me, or do whatever, say whatever you think might be a better way of doing something. So I always appreciate that. So let me mute my phone here just to make sure we don't run into any crazy stuff, and then we'll be good. Cool. All right. So the first thing that I am going to do is I'm going to do a SOP create, and we're just going to make some geometry here, right? So this is just going to be a little asset. It's not going to be anything overly crazy. I'm thinking just going to make like a little, like, really simple tree, almost like just something super simple, just so that we could kind of talk about maybe the different pieces of it, and how we can import this once we've got it created as like a USD asset. So this is what we're going to do. So this I'm just going to call tree, because that's going to name my component here, because it's going to name my top level primitive right here, $OS. So let's jump inside. I am going to just rehome that. And I think what we're going to do is we're just going to build a really simple network here. So I'm going to just make this a little smaller. So we're actually even going to add the ground in here, just for some visual reference. Let's also, I'm just going to do a merge here, because we want this all to kind of come into one input. So, or through to one stream of geometry. So let's do that. Let's do a tube just for the trunk. We'll do a match size here, just to put it on the ground plane. We're gonna make this a little smaller. So let's just come up here, just reduce the size of it a bit like that. Throw this in here. Cool. Okay, so we're gonna do it something like that. And let's do some cones. Well, I guess we'll just do some tubes. Why did I think maybe cones are a Solaris thing? That's interesting. I thought there was a cone. Why did I think there was a cone primitive? Oh, you know what? That's so weird. Yeah. Anyways, we'll just do a simple cone. That's fine. So let's just center this up. We're going to put end caps on it. The top I'm actually going to scale way down. So we'll just set this to 0. Well, for these ones, we don't need to do that. So we'll just, oops. We'll just make it like that. Maybe like that. And we're just going to make like a really silly looking Christmas tree here. So let's just do something like this. I'm going to make a duplicate of this. And we'll move this up. We'll just scale the radius down a little bit. Like so. And we'll do one more. Like this. Please enjoy my wonderful skills here. Oh, man. Make this a little higher, I think. No, maybe a little shorter. All right, whatever. It's a Christmas tree. We'll just call it that. So we're gonna do that. Then what I'm also going to do. So let's do this. Oops. Let's do that, and then I'm actually going to merge these all together. Sorry. So these are all going to get merged here, like that, because I'm going to use these all together. All right, so these are going to be our, I don't know, we'll just call those branches. And then what I'm going to do is I'm going to union these all together and add some, like maybe some little pine cones to it or something. So that's just going to Boolean them all together. Gonna just going to blast this off because we don't want to have them down there. And also going to blast this and this. So we're just going to put some pine cones around the outside of it. So let's do a scatter. Maybe, I don't know. Maybe we'll do 50. So this is just going to be a really simple thing. I know it's going to take a second, but hopefully you'll see how this works and we'll be good. Okay, so we're just going to do a sphere here. I'm going to, I don't know, let me try to think of how this shape is going to be. What the heck does a pine cone even look like? Thinking here. What does a pine cone look like? Yeah, it's basically just like flat at the bottom a little bit. So let's do that. So we'll take this sphere and I'm just going to do a transform. Actually, I can just do a soft transform. That's soft peak. All right, so soft transform. And we're just going to do this on the very bottom here. Yep. Got the back selected there. That's weird. All right. S4, we want to have no visuals. That's right. What is going on here? Sorry. All right. There we go. Cool. Whatever. All right. So let's do a copy to points. And let's just p-scale these. Attribute adjust float will be fine. And we can set these to a constant value. Sure, that's totally fine. I'm not really too worried about this. Heck, could be a Christmas tree for all I care. We're just going to use this as a little example anyways. All right, cool. So let's now see exactly what we've got going on here, right? So we can see that we just have our tree and our mesh, right? If you remember last time we talked about you can add a path attribute to kind of change the hierarchy of your geometry, right? So that's what we're going to do. So I'm just going to add some these name SOPs here. I think these are helpful. So we're just going to add a path here. And so here we're going to say /tree/ let's call this geo /ground. Let's do that. And then I'm also going to put a slash there, I think. No, it doesn't matter. That's right. So like that is good. Cool. So then what we could do here is we could say ground /trunk. So now we have a trunk that's parented to that. And then let's take this here and we'll just call this branches. Actually, you know what we're going to do? We are going to set up a little hierarchy here, I think, first. So let's do that. So here we're going to say tree /geo/ say ground /tree, like so. Let's do that. And these are all transforms. Great. Okay, so what we're going to do instead is we're going to say /ground /mesh. So that's the ground mesh. So this is going to be tree /trunk. And then this is going to be branches. And then the last one is going to be the pine cones. Okay, so here's everything attached to the ground. Here's everything attached to the tree. Here's the geo, right? And we have our tree asset, like so. Let me just maybe organize. No, I don't want to do that. All right, so there we go. We've got that. This is good. Let's just kind of clean this up a little here so we can see better what's going on. Great. Okay, so we've got our asset being built here. I'm going to put an output like so. Let's also color these just to make them a little bit more interesting. So we'll just color this ground, color it actually, you know what? I'm going to color that like a green grass color. And then this can be brown. It's funny, these are all green and brown. Let's make this like a really deep, like saturated green. And then these can be an even lighter brown, maybe. Okay, great. So we have our little asset here. It's not that interesting, not too interesting, but this will give you an idea for what we can do here. All right, so let's write out a USD ROP here. And what we're going to do is, yep, we got all of our meshes in here and everything. Great. So what we're going to do is we're just going to write this into our USD folder. And we're just going to call this $os.usd. And let's call this tree asset. All right, we're going to save that to disk. So just to prove that we've done exactly what we said we were going to do, let's take a look at this. Houdini Hangout. Okay, so here is our tree asset.usd. We could also save the USDA format and be able to read it. If we look at some of these, we can see that there's, there's display. There should be a display color on these. Let's see where. Yep, there it is. Primvar's display color. Cool, great. So let's look at that real quick. The USDA file. We can take a look at that. Thanks. Trust that. All right. So if we look at this, we should be able to see that it's all good. So we've got those transforms. This is basically the code here. We're writing out a tree, then a geo, then the ground, transform tree, mesh pine cones, mesh branches, mesh trunk, and mesh. What is that one? Oh, yeah, because I named it funny. That should actually be like ground geo, something like that. All right, that's a little bit more properly named. So now if we look at this, it should actually just update and be ground geo. Great. All right, cool. So that's all well and good. We've got this hierarchy, right? So now let's talk about how we bring that back in. So I think we touched on this just a little bit last week, but let's look at the sublayer node here. And so what a sublayer is going to do is basically just bring that file on disk exactly the way we saved it out. So let's take this and we'll say get, we'll say sub for sublayer tree asset. And when we do this off a disk, we're going to see, we'll just, I'm going to resave this USD because we don't need to have it human readable. So we'll do that. And let's take a look at this here. Okay, so now we're sublayering this in, right? So now this is coming directly from disk, right? We're bringing this file in directly from disk. It's loaded. There's not really a whole lot we can do here, right? We can reload the file if we need to. We could bring in more files if that was helpful. But for right now, there's not a whole lot we can do. There's, we can make sure that payloads are loaded and, do some stuff with the sublayers that are within there, but basically it just brings the file in as is off disk. So that is the sublayer node, basically. It just brings everything in exactly the way it was. And I think we touched on that a little bit last week. But instead, let's take a look at the reference node. This one is a little bit more interesting, and it allows for some more control over what we're going to do. Hey, Mehmet. Thanks for joining us tonight. Welcome to the stream. Glad to have you. So, okay, so let's take that same file, take the USD, and we'll read that in. And so really not a ton is different here at first glance. Everything seems pretty normal. However, one thing that we're going to be able to see here is that this has some more settings in it, right? And yeah, Carlos, that's exactly what we're going to do right now. So we're going to take a look at that. So right now what we're talking about is the reference node. So yeah, it's a subtle difference, but I think you'll see the power of each of these different options. So right now what we're doing is we're bringing in this file pattern here, right? But there is also a primitive path that we can set. And so this is kind of interesting, right? Because what we could do here is we can actually tell Solaris where to put this in our USD scene graph. Okay, so let's just set up another primitive here just real quick, just to give us some extra stuff. So maybe we'll say forest slash, maybe actually I'll say, I don't know, national, I'm just going to name it something weird, national park, forest, grove, trees, something like that. I don't know. So now we have like a little hierarchy here, right? And so we have something that we could put it into. So if we put this input stage here and then have our reference, we still keep, you know, whatever's coming in here. So now what we can do here is we can kind of control where this tree asset goes, right? So right now it's using the source name. So it's using this string right here. It's not using the .usd, but it's using tree asset.usd. Now we could also say, instead of source name, let's do $OS and just use the node name. Okay, so now we have it called reference one, right? So we could also say this is a tree and it'll name it that, right? So we can control this. Over in this sublayer, oh, cool. Waterfall is a school project. Nice. Welcome, Ruslan, maybe. Welcome to the stream. Cool. That's awesome. Hopefully this will be helpful for setting up maybe some environments and scenery and thinking about how you could maybe use Solaris to do your layout in. So be cool. Very nice. Okay, so we can change it by $OS, but we can also just select a primitive path from anything in our scene. So if we control click on this, that'll bring up a little dialog here. So what we could do is we could have this, we could select trees right here. And now our trees are going to be what holds that, right? We could also say single tree like this and do it just like that. So now we have a single tree that this hierarchy is getting set to. So there's a lot of different ways that we could use this primitive path here in order to like place it in a different place in our hierarchy, right? So we could do this just like forest, right? We could just put it in forest like that and say forest and then single tree like this. And so now we have this grove and the trees here as well that don't have anything in them, but now our single tree is branched off like that. So we can really control where this tree asset is going to load in our scene using the reference that way. Now, the other thing that we can do in here, we can also set the primitive kind and the parent primitive types. Now, these already have parent primitives, so it's not really going to do a whole lot. We could also turn this off, right? And now these aren't being defined by this earlier primitive path or this primitive up here that we'd created. Now it's just on its own and it's creating these, and we should be able to change these pretty easily. So now we could set those as scope. So there's some flexibility here. We could just create a hierarchy if we wanted to right from here, right? So there's a few different ways that you can kind of work with this, and there's a lot of flexibility in USD. So it's something to keep in mind. Let's turn this back on. There we go. Cool. Now, the other thing that we could do instead is instead of referencing it, we could payload it. And if you remember, payloading means that we could actually unload this in the viewport and see, kind of get a sense for, take these things and unload them in the viewport. So first of all, what we're going to do here is if we unload this in the viewport, as a payload file, it's just going to disappear because we haven't really set it up properly. Now, normally when you're creating an asset through something like the component builder, which we talked a little bit about last week, that will actually create your bounding box for you. Now, what we could, I think would work here. Now let's see here. Let's see if we do this. Extents. I think with this we could just say all geometry primitives, set the extents, and then maybe this. Let's see if this works. Might not, but we'll see. All right, so let's reload this file. No. So you have to really set this properly and give it, give the information a better hierarchy to be able to see the bounds. This is just a really kind of crudely made asset. So in order to see the bounding box, you need to use a little bit better setup than what I have here, just these couple nodes. But we can set it up as a payload, which will allow us to load and unload in the scene. Imagine if you had 1 million trees, you needed to unload a whole bunch of them, except for maybe a few hero trees that you were working on. That would be a way that you could do it, where you could use a payload and unload just certain trees in your scene. So that is kind of the help, like that's the helpful part of reference, right? You could also, instead of referencing your automatically chosen primitive, we could do a specific primitive. So what we could do here is we could reference in just a specific primitive in here. So let's say we just wanted the tree. We could reference in just the tree, right? Or we could do something like just the pine cones and get just the pine cones in. Right, you can see right here, this is coming in as single tree. So you might want to just call this, pine cones or something like that. And now that mesh is attached in here, and just those pine cones are loaded. So these are kind of the two really helpful things that reference gives you that sublayer doesn't. You can select a portion of your scene graph in your file that you're loading and just load that section in, right? So your hierarchy in here, right? If I selected something like tree, that's just going to select that. Or we could say maybe, you can only select one of them at a time. You can't select multiple ones. So if you wanted the whole tree, you could do that, right? And there's your whole tree. We could also set just the ground geometry and just that'll come in, right? Because there's nothing lower than that. So these are some of the different ways that we can select based on primitive paths and based on, place it in our scene using the primitive path and select parts of our asset that we're loading in using the reference primitive path. So when I do automatically chosen primitive or default primitive, those are going to be the ones, those are based on kind of how the file is set, on disk, how it's saved to disk. Now, when you go to specific primitive, that's whatever you might specify in your hierarchy. So this is the real power of reference, right? So there's a couple other things in here that are a little bit higher level. And if you're interested in these, I would honestly look them up in the documentation because these are going to be some really deep things. So you really aren't going to have to worry about that too much. Really, the created primitives and references is what you're going to need. So we also were talking about asset reference, right? I know Carlos asked about this. So let's do the same thing. Let's reference this tree asset in. There we go. So again, we can use a few different things here, right? So we can use this reference file. We can reference automatically chosen primitive, and let's also just attach it to this same stage here. So to this same primitive. So here we have our asset reference 1. Now this, by default, its destination primitive is the name of this, right? Asset reference 1. So what we might want to do here is select, maybe we'll put this in the Grove primitive, right? So we have geo, ground, tree, like that, whatever. And maybe here we say $OS just to make another primitive that this is going to go into and call this maybe hero tree, something like that, right? So here's our hero tree sitting next to this other trees. It's got our geometry, ground, all this stuff in it, right? And we can also reference a specific primitive just like we could before. We could go in here and say, okay, we just want the tree to come in, right? Here's our hero tree. There's no ground with it. Great. All working wonderful. Now, the really nice thing with this is that we can have some transforms with this. So really for this asset reference, this is great because we can move it around in our scene without appending another transform lop to be able to do this. So we could rotate it, we could do whatever. So having this asset reference here is going to give us the ability to move this around in our scene really quickly. So if you know that you're going to be, making changes to its position when you load it in, it really might be smart to use the asset reference versus a regular reference, especially if it's something that's kind of self-contained like this tree, and we know that we're going to move it around or place it in our scene, however. So that is one of the major differences, is your transformation. The other thing that's kind of important here is the variance. If you remember, we talked a little bit about variance last stream, and if you haven't read that, I'd go take a look at that. But we could honestly we could do another one and use one of these assets from last week. So let's do that just to change this up a little here. So we'll set this back to OS. I'm going to call this can asset. We don't need the rest of these. So let's just do this on its own, and we'll bring in I have a couple assets here that we made. So let's do the limited soup cans. Here's our limited soup cans. We'll hit accept. Oh, because that doesn't exist. Let's just see here. What's going on? Okay. We have a view mask here. There we go. Okay. So we have our can asset. I don't know why the other one wasn't working. That's really weird. Oh, it is. It just was unloaded in the viewport. Ha. Duh. Another little gotcha there. If you're ever working on this and you unload your payloads in the viewport, that'll really mess you up. So, okay, so here's our can, right? We have our can asset here. We could move this around because we're using our asset reference. And so if we go into our variants, we can set a variant here. So this has variants on it. This is an asset that's a lot better formed. Now this one doesn't allow you to see the payloads in the viewport, but the other one that we had did. So that was what was what tipped me off here. So if we look at this, you can see that if we unload it in the viewport, there's a little bounding box on it. So this one was made properly. I don't know what was wrong with the other one, but anyways, there it is. So we're just going to go back to this one because this is a little bit simpler to understand. Great. So let's look at the variants. So we have a variant set on here. We have can options that we can adjust. Now there's also a material variant, but there's just one in there. It's just P's material. So that's the only option. So let's look at instead of the material, let's look at the can options. So here we have canned corn, which is actually tomato soup because I changed it and didn't name it properly. And we have tuna fish here too. So there is our tuna fish. This one is tomato soup. And this one is your peas. So that is another one of the really strong benefits of working with your asset reference. You have the ability to set your variants when you're loading your assets. So like if we looked at this other file that has my flexible soup cans in it, which does not mean that they bend, it means that there's a lot more options in here. So I'm going to change the variant sets here. So let's first look at the can geo. We could set all of these. We could do can material. We could do label material. So the can geo, we could say, let's make a tall can because we have a tall variant in there. Let's do a rusty material here. So we've got the really rusty top. And then let's do, chicken soup. So this allows you to set all those variants as you're loading it. And it's super, super powerful when you think of it that way, right? Because if you had an asset on disk that had all of these variant sets in it, in order to set that, you'd need another node. You need to ref. So if you were, say, doing this, you're moving it somewhere and loading in all these variants, you could do it from a regular reference, but you would need a transform and a set variants right after that node in order to set those all as you're going. So again, these are a little bit contrived examples of this. These aren't, production examples, but hopefully you can see how these work and what the benefits of each of these different methods might be. There's times where you just need to reference something in and you don't want to have transformation and variance and all that kind of stuff. In that case, just use a reference. There's no reason not to just use a regular reference. But if you know something is already like ready to go and has all these variants on it, and you're going to want to place it in your scene and do some transforms on it, then use the asset reference. And if it's something that you need to bring in with its full hierarchy the way it was and not change anything at all, then you use a sublayer to do that. So those are kind of the three different ways or methods that you would use to import geometry off disk that are USD files already. Because last week we talked about kind of creating some assets with the component builder, doing a bunch of other things, making assets to some extent. And now when you want to bring them back in, you need to kind of know how to do that, right? That's kind of the other step here. So hopefully that makes sense and is fairly clear. This again is not any type of overly flashy demo, but I think it's practical to see what these different options are for bringing your geometry in. So another one that's a little different is the stage manager. So this one's similar, but quite different, really. So the stage manager is interesting because you can do a couple things with it. So what we could do is we could go in here and we could grab these different things to bring them in. So let's do this. We've got a pig head asset here, right? So whatever, this was one we made last week. So we have a pig head there. I'm going to open this up. So what we do here is we open this little folder dialog, and this gives us access to this tree view here. So this is going from our current HIP file, basically. So here's the USD folder. Here's our, we could bring in this limited soup can if we wanted to. We could bring in our flexible soup can. And these all have transforms, so we can move them around. So the pig we could, put over here, move it up above the ground plane. We could take this limited soup can geometry and move it over here somewhere, maybe rotate it so the label's facing us. This one we'll put over here like that. And we could do this multiple times, right? So we could bring in a few more of these flexible cans. We could also rename them, right? So you can see that this is starting to build this hierarchy over here, right? So this hierarchy is matching this hierarchy here. So you might say, okay, well, that's interesting. Like, it's kind of neat. You can do that all in one node, right? So let's also bring in our tree asset, right? We've got our tree. So let's bring that, and we'll maybe move that. Sorry, let me just, I'm clicking on the wrong one. So there's our tree asset. Let's move that over here maybe. And we'll just do some more of this here. So let's do this, and then we'll do this. We'll just kind of randomly place these around, right? Cool. All right, so we've got some random assets in here, right? So that's all well and good, right? We're creating our hierarchy here. But what if I'm going to close this panel here right now. So what if instead of that, what if we wanted to change up some of these elements and maybe we wanted to group all the cans together, things like that. Well, there are some really nice things that we can add here. So we could add a primitive here and say, instead of new child, we could call this cans. And then we could take all these soup cans and drag and drop them underneath here. So now we have a cans, group with all of our soup cans underneath them. And that's all. This is all being done just in this one stage manager node. So this is pretty powerful from that standpoint. You can do a lot of stuff with this. The other thing we could do is we could go in here and set some variants, right? So each of these we can set, multiple variants on. At least it seems that way with the UI. So let's see what happens here. But let's say we wanted to take our limited soup can and let's change that to the tuna fish can. All right. So now we've got that set to the rusty tuna fish. Let's do one of these without no label, and we'll say it's we don't need to worry about the label. Let's do mild rust, and it has no label. So there we go. There's our mild rust. And then maybe one of these other ones here, we'll just kind of change them around a little bit. This one will be tall, and it'll have the canned corn label on it. And we'll call that one, oh, it's clean already. Great. And then let's do this one as a short one, and we'll just leave the tomato on it, right? So now you can see we can set the variance here in this, and maybe these two go into a, maybe this goes into a miscellaneous folder here, or group. So we'll put those in like this. And so you can kind of think of this as a way to kind of load a bunch of stuff into your scene and set their hierarchies, do a bunch of transformations, all that kind of stuff. There's a lot that you can do with this one stage manager node. It kind of is all of those elements together in some ways. And there's different ways that you could use this, right? You don't have to use it just as one stage manager. You could use this stage manager and then have another one after it that brings in more stuff and group that into its own sections and things like that. So maybe each one does, adds things into your hierarchy, things like that. So you can kind of be flexible. That's really the beauty of USD, is that you can be so flexible with it. There are specific rules that can get you hung up, and that's why we're trying to kind of talk through some of these things, but there is a lot of flexibility also inherently in the way that it's created. So, we did all of this, but this view seems very not Houdini, right? This seems like this kind of, it's a nice UI. It's really, really clean. We could take something like these flexible soup cans, because I know they'll unload, and we should be able to unload those payloads, maybe not. That's interesting. What if we do this? No. Okay, that's interesting. For some reason, this isn't unloading those payloads. That's strange. I don't know why that would be the case. The other thing too is you can add child primitives underneath these too, right? If you needed to, so you could add a new child there. However, I don't want to do that, so we'll just leave that. Cool. Okay, so this is a nice viewport. It's a nice view or this nice UI. But what we want to, if we go up here to these little kind of sliders, we can change the way this looks. And now this looks quite a bit more Houdini with all these parameters and, strings and things like that are all populated in here. So this is everything we've done to these assets on disk as we're loading them in. So we might be creating primitives, referencing things, right? Creating primitives, maybe moving them, creating a primitive called miscellaneous, moving a primitive. There's all these different operations that we can do, even delete primitives here. So these are all, ways for us to be able to, you could actually do this, from a procedural manner, right? You could actually do this on the back end if you wanted to, and use the stage manager to do all these changes in one node. So there's a lot of, different ways that you could work with this node, and it's pretty powerful, honestly. The only bad thing is that it's all encompassed into one node. So if you want to bypass it or, kind of see what's happening, it takes a bit longer to kind of process all these different kind of multi-parameter tabs to kind of go through everything. And obviously if you did 100 things, it could get kind of messy and long. So there's positives and negatives to each of these. There's a really powerful node, but could be hard to understand exactly what you did when you loaded them all in. So, these are things to kind of weigh as you're, as you're building assets and things like that. So yeah, something to certainly keep in mind and, think about from that standpoint. But, yeah, so hopefully Carlos, hopefully I touched on the question you had there and was able to kind of clear that up for you a little bit. Hopefully that's all making sense and is pretty straightforward, hopefully for you to understand now. And if you have any questions beyond what I was able to explain, I'd love to hear. And, anybody in chat, I'd love to hear from you guys and just see what see what your thoughts are, if you have any specific questions to how we're doing this, or maybe you've come across something similar that's a similar way or a slightly different way of importing stuff, but you're not sure why that even exists or why I haven't gone over it. Please drop that in chat. I'd love to be able to kind of talk to those different thoughts and ideas. So. All right. Well, let's keep going, and then we can kind of touch on some other things here. So far we really haven't looked too much at one of the most powerful parts of USD, and that's the ability to layer files on top of each other, or sublayer files on top of each other. And this is really kind of the whole point of USD, right? And so you might think like, okay, if you're making an asset, how would you even go about, breaking things up into separate files? Like in this case here, we have this tree and it's going into this one file here. How would you really ever break that up into separate things? Like that doesn't make a ton of sense. So we could do that for sure. And the way that we would do that is, there's a varying number of ways that we could do that. Like I said, USD is really flexible, and so it gives us a lot of chances to do things many different ways. Sometimes it gives us the opportunity to do things really badly. And there is like one thing we'll talk about a little bit later here, but let's first take a look at something maybe just really simple, like using one of these pig heads to just kind of demonstrate how to kind of save things out differently in your scene. So I'm just going to call this loading, or we'll say importing, just to kind of clean it up so we know what we're looking at here. So we're not getting too hung up on stuff. All right. So let's do a pig head here. Just bring the test geometry pig head in. This has the, actually, no, sorry. Not going to do that. We're going to do a SOP create because we don't want to have all of that stuff there. We don't want the shaders and everything in it. That's fine for normal, but let's just do a pig head in here. And we're going to turn off the shaders. We're going to leave him on medium, maybe add some normals to it. And then let's do a match size, and we'll just set this to minimum just so it's on the ground plane. And then we'll do an output just to make sure that the geometry is coming out of this stream, and it doesn't matter where our view flag is set, right? Okay, so now we've got our pig head here. What we're going to do is we're going to say, let's just say pig asset. Oops, we need a slash at the beginning of that. Just like that. So we've got a pig asset, SOP create. Oh, I forgot. Sorry. We don't want to have this group up at the top level. We want it to be a component at the top level. So let's do this. Sorry, just thinking here. So what I'm going to do is I'm just going to call this and then I'm going to add a path here. So we'll say, we'll just do a path here. Or sorry, use the name SOP. This is really the best way to kind of organize your primitives here. So we'll say pig asset slash pig asset slash geo slash we'll say pig mesh. There we go. So now we have our path set, right? Cool. Good. I'm glad this is helpful for you. Yeah. Material X, you can reference Material X in as well. That's 100%. Wallaby just mentioned that in chat that you can reference in Material X files, and that's true. You do have to be a little careful with Material X because if it's not formatted properly, you could get some weirdness there. I think some of the stuff I've seen online, I remember somebody mentioning something in a chat at one point or in some sort of talk or something that I saw, that some of the Material X stuff isn't formatted exactly correctly for use with USD, so you have to be a little careful. But yeah, Material X, you can bring it in and use it that way too. And you would want to use a reference for materials because you wouldn't really want that to just come in at the top level of your scene, right? So having that as a reference is great because then you can tell it where to go inside of your asset. So, okay, so we've got our pig asset here, geo pig mesh, right? Cool. So that's coming in the way we want it to. So that's great. And let's just say we wanted to save this to disk, right? As one file, right? So let's do our USD ROP here, right? And say, this will say, we're just going to call this geo. And we'll just use OS. And we'll save this as USD. ChatGPT 4. Yeah, so Carlos is saying, that the stage manager wraps a lot up into one node. And is that a good thing or a bad thing? I think it can be good. It can be bad. I mean, if you know ahead of time what you're doing and you really have a clear idea of where you're going with your scene, the stage manager can be a great tool because it'll let you bring in a ton of stuff and kind of arrange it the way you want it to. In fact, if you go and watch my presentation that I did not too long ago from on the website. I'll throw that in chat actually in a second here. Let me see. News feed. Yeah, it would have been in here. Sorry, give me 1 second. Here. Maybe. Yeah. So this right here. So if you go to this, you'll see cool. So that is a little thing about doing layout in with Solaris, right? But what I do is I actually set up a bunch of, I'm using a bunch of Quixel Megascans, and I was just kind of arranging them, a bunch of these USD assets that I'd created just on the ground, and just to kind of quickly create like a ground plane to work with. And that was really helpful because I knew like, okay, I want to bring a bunch of these elements in, kind of set them up, arrange them in some way quickly without having to reference in things multiple times. If you're interested in scene layout in Solaris and with USD, I would take a look at that video, especially if you're doing like a project or something like that where you have like an environment that you want to build. It gives you a sense of how to use some of the layout tools, which we probably will talk about in the next chat a little bit, but that's like a fully fleshed out presentation that I did, so it should be quite a bit more flashy and nice. It also goes into Unreal at the end, so it's kind of cool. But yeah, the stage manager is great, and really that's the only way that you can you can't drag and drop your scene graph tree. You can't like drag them up here or anything like that. So which this is just a viewer, right? So you could bring in like this tree here. I believe if we did a stage manager, let me just double check here. Actually, I forgot about this. Think if we do that, oh, right, we're in the parameters view, so we'll uncheck that. Yep. So wait, what happened here? Oh, let me get rid of this. I don't know what happened there. Stage manager. Okay. Yep. So if I drop this tree into the stage manager here, it will actually grab the hierarchy of it, right? And I could move this around. So I could actually take this tree and move it up here, right? So pretty crazy what you can do with this. You can actually reorganize your scene graph tree with this. Now, the thing to remember here is that this is not very procedural. Rearranging your files on disk like that can be really dangerous, because if you were to take, like, if this, instead of being just stuff in Solaris, if this was a file on disk, like if you were sublayering this in like this, right, and reorganizing it the same way, yeah, it did the same exact thing. It moved the tree over here, right? So if we turn this on and off, it's moving the tree out like that. Great. But if we, brought it back up here like that, sure, we can do that. We can tick this on and off, right? However, if someone else is working with this file on disk and does something to your tree, branches, whatever, now this tree is in the wrong hierarchy. Its path is incorrect compared to what was on disk here. So restructuring your scene graph is kind of a bad idea if you're not doing it right at the beginning of your setup, like before you write something to disk. After doing it after something's being read from disk is like, it could be real sketchy. So yeah, it's good and bad, but great comment, Carlos. I really appreciate that thought, because it's mind blowing, but there's also like, man, this could be really bad. So yeah, cool stuff. That is a really good node. So this pig asset, right? So let's say we wanted to just save out the geo for it, right? And we wanted to save it to USD assets, and we're going to make, actually, you know what? Instead of doing the pig head, let's do something else, because we have a pig head already. Let's do a toy. If I can type, yeah, let's do a toy instead. We'll take the shader off as well. So we're going to change the name of this here to, hello. That is really weird. All right. I don't know what just happened there. I freaked it out. All right, let's just paste that back inside here. Is my scene graph not? What is happening? Oh, it's because I have the path set. Sorry. I thought I'm losing my mind. I'm like, what in the world is going on here? It's because this path is set. Sorry. So instead of pig asset, we should name this toy asset. Not you, toy. Geo. And then we'll call this toy mesh. Okay. Sheesh. Thought I was losing my mind. There we go. So we'll say toy asset, just like so. And we could save it to this geometry file here, right? And then let's just save this as USD asset. Is that what it was? Assets, plural. Then we'll say toy/OS. Yeah, no problem. No problem, man. Glad to help. All right, so here we go. We've got our toy USD. It's going to be saved as geo. So if we look in here, we now have a file called geo. We could just sublayer that in just to take a look at what exactly we wrote to disk, just for kicks. Here's our toy, geo.usd, and there it is, right? Came off disk. Great. But what if we wanted to have each of these things saved separately? So we wanted to have our toy asset and save that to geo, but then we wanted to do something like a material library here, right? Because maybe you're working with a group of students, or you're working in a studio and you have like one guy that's doing all your shading, and then somebody else that's doing, modeling, and then someone else is doing your lighting and scene layout and stuff, right? Well, okay, so let's just kind of pretend that we're kind of moving this around to different places, right? So we'll just use a principled shader just because it's quicker here, and I've got a few presets. So I'm gonna do, I don't know, we'll just do a silver color here. So we'll have a silver material, and instead of it just being in materials, I'm going to put it under the toy asset /MTL like that. So it has its own little material section here. It doesn't need to be a transform. It can just be a scope. But this is a primitive that can't be transformed. It's called a scope, and so we can't transform that around because we don't need to worry about that for materials. So we'll say just, I don't know, create shaders, and then let's assign them, right? Assign silver shader. So let's take the primitive that we want to assign it to. Let's assign it to the geometry just in case we added anything else inside of there. There's our geo. And then let's select our material path. Material path is principled shader. Actually, I'm going to just name that a little better. So we'll call this silver. And let's grab this. Silver. Okay, cool. So we've got our silver material on Flippy here. So that's great. And so, okay, so we're going to save out this geo here, and then so we did that, and let's say this will be material, right? And I'm just changing the name of this because it's $OS. So this will be our materials the materials and assignment that'll get saved out, right? So let's hit save there. And let's take a look at that. Let's load that from disk. Let's keep a sublayer over here. I should not have deleted that. So let's do that. And there we go. Okay. So that's interesting. So it brought our geometry in as well, right? Because this chain is going all the way down. So we can't really do it this way. This isn't really going to work that well for us. So it's kind of strange, right? This is a little bit of a weird way. Like you can't really do that, right? But the cool thing is that in Solaris, there's this thing called a layer break. And layers are just kind of another name for the files, right? That are USD files. And another thing that not a lot of people look at is your scene graph layers. So if let's just shake this real quick. So scene graph layers right here, right? So if we're looking at our silver shader, we look in here, we've got a root layer. We have this. There's no save control on this, which is interesting. It's just implicit, and it says save path not set. So, okay, so when we get down here, interesting. We have this material. So what if we put this in here? What happens? Okay. So now we have some interesting things happening here. We now have two layers because we have a layer break. So we have this, and it says save control above layer break. And what that's going to tell us is that anytime you put a layer break right here, it has a nice little text in it to tell you what's going on. It says the layer break node starts a new active sublayer that subsequent nodes will edit and indicates all previous layers will be discarded when saving to disk. So right now you can see everything, but this is saying everything above it is not going to get saved to disk. So now let's save this and see what happens. So let's go over here and look at our material. And now we can see that there's some information here, but our geometry itself is not being loaded in. So, okay, so we're getting somewhere. So let's see, we'll say sublayer material like this. Let's also sub. So now let's look at this. Okay, so now let's bring in our geo here, right? And then let's connect these together and see what happens. And now we're back at the exact same place. And so we have our geometry written here, we have our material written here, and we can then, continue on through the line and have these things, kind of independent of each other, right? So let's kind of keep going with this and maybe do something not interesting, but something a little more unique with it, right? So let's now take these and do something like, I don't know. Let's use a duplicate. This is a pretty straightforward node. I think we might have used it last time. Let's just take this. I'm also going to do another layer break here because we don't want this to get saved. We're going to split that out. And let's do a duplicate. What I'm going to do is say source primitives are first duplicate. I just kind of like that better because then it's not high. This first one is just staying as it is. Otherwise, it's if you say, I think hide source primitives, it just turns them off, but they're still there. So we're going to say source primitives are first duplicates. We'll just make a few of these and we'll translate them over, right? Like so. And so the interesting thing here is we're duplicating our geometry. So we got geo 1, 2, 3. So these actually aren't getting any shaders on them, right? Because our shader assignment is just on geo. So let's change this up a little bit. So instead of doing this, let's see if we can't do this. I think we could do this. And there we go. So now we're just duplicating our meshes, right? So we have multiple meshes here, and that's working. We've got our shader assigned because our shader assignment is on geo here. So if we go back to our scene graph details, we can see material binding. Yep, there's our material is bound to that. So everything underneath that is going to have the shader applied to it. So great. So we have this duplicate, and then let's take another one of these and we'll just call this one maybe layout, as if, you know, we're setting up a scene or something here, right? So we'll save that to disk. Oops, what, it didn't like something there. Oh, interesting. Got a little error there. Let me see. Let me see if that just is a warning or if it actually worked or not. Okay, so instead of this, let's grab layout. Okay. I'm not sure. It was a weird warning. I'm not sure why that's coming up. But anyways, there we go. So now we have this sub layout. Okay, so hopefully you can start to see sort of the interesting nature of how USD works, right? We can actually have each of these files that only hold, you know, specific parts of our scene, right? Let me distribute these vertically, just like that. Cool. All right, so we're sublayering all these things together. But what if we didn't want that shader on there, right? What if we wanted to do something different, for example? Well, you could rewrite this. The other thing is you can just turn this off, and that's going to stop assigning that shader, right? Nothing else is changing here, right? We're just skipping this middle part of this kind of scene creation. And I think there's things about USD that don't work like Houdini does, but because this is represented by a node network, you can imagine it's like just turning off this whole section of nodes in the middle here. It can just layer on top of each other like this. And you don't even have to do it in this order. You could do it like this, and that's going to be just fine. There's no problem with that at all. So USD is really flexible, and it has the ability to kind of layer on top of each other, right? So let's just take a look at what these files look like, right? Because, you know, normally you can't just write a file and see what they look like. Now I'm going to select all of them and hit save to disk. This seems like kind of a dumb way to work. So we'll talk about this in a second on how to make this a little bit better. But let's load those up. So we've got our geometry. So we're going to look at these. I know these are going to look a little scary, but let's take a look at them and see really what's going on inside here. Here's the material, and here's the layout. Okay, great. So let's first look at the geo. Now this is really, I think, really straightforward, and it looks like a lot of information to kind of process, but let's kind of break it down. So this top part is literally just kind of like header information. It's saying what the default primitive is, you know, your time code, frames per second, blah, blah, blah. Great. Then we make a transform primitive called toy asset, and it's a component, right? Then we have some transformation data. We have, you know, the operation, you know, the transform stuff, whatever. And then we make a geometry xform primitive, And then we define a mesh primitive here that's called toy mesh. So just remember, this is exactly what we're talking about here. Toy asset, geo, toy mesh, right? So we're going to go back up to here just to look at what this looks like. Okay, so it's creating just this. And then inside of here is all this stuff, right? It's like, oh my gosh, there's so much here. But really all we're dealing with is the extents of it, right? How many, what the bounding box for it is, the vertex count. So these are all quads. What are the indices for the vertex? Normals, points, this is point positions. The primvar, this is the UVs. UVs get transferred to ST in USD. And then there's just some things down here for saying what kind of indices we have for any of these primvars and what the subdivision scheme is. And that's it. So like, yeah, there's a ton of information here because there's a bunch of, there's a whole bunch of, different, primitive IDs and positions and things like that. But it's really just like saving the geometry spreadsheet in text form, from standard Houdini SOPs world. So that's the geometry. Then we get to the material, and this is a lot longer of a file, but I think it's even easier to understand because what we're doing here is we're literally just saying we're overriding toy asset. We're defining the scope here, right? So this basically we're laying this on top of toy asset. Then we're defining a scope called material. We're defining a material called silver. And then these are all the shader informations here, right? So like, here's your base color. Here's your base color texture. Texture wraps and base color used, all these different things. These are just kind of the inputs to the shader, right? Occlusion, texture wrap, blah, blah, blah. Things that we really didn't set. Then down here, there's also a shader called silver preview. If you look at the material library, we're generating a preview surface shader. That's how we can see it in the viewport. So in here, we can see that there's a silver preview that was kind of made under the, behind the scenes for us. It makes a USD preview surface, which makes sense. And then it sets a few things for it just to make sure that it's visualizing properly. And then right here, the last thing we're doing is we're just saying over geo, which is this right here, geo. So we're laying this information on that geo primitive and saying, just apply this material binding to it. So we're applying that material binding to that geo primitive. So again, there's a lot of information here. There's a lot of data here, but really it's not super complicated. We're just doing a couple things here. And yes, it all has to be written out, but I mean, obviously if we wrote out all text for everything that Houdini does in a normal network, it would be mind-boggling, right? So we're just doing a few things, but there's a lot of little details that it's doing on, under the hood for us. So then finally, we get to the layout. And so what we're doing here is we're overriding, we're doing an override on toy asset. We're defining this transform geo. Then we're defining a few different meshes here because one of our meshes already exists. It's toy mesh, right? And so then we're gonna have toy mesh 1, toy mesh 2, and toy mesh 3. Now this is the really interesting thing that USD can do. Here, we're looking for this reference here. So we're looking for this path here, right? Toy asset, geo, toy mesh. So within the code of USD, we're basically referencing another primitive that's on our USD stage, like in our USD scene. And we can actually reference that and duplicate it. So it's actually making duplicates of this, right? So it's duplicating this information for us, which is really interesting. And really, then all we do is have a transform, basically just transformation information where these are going, right? There's just some transforms that are changing. That's it. So again, it's not super complicated, but that's all the information that's saved in this file. And that's why you can lay those in any order, right? Really, you'd have to start with the geometry first, but you could arrange those sublayers however, and it's just going to override this information and lay it in there and create the things that it needs to. So that is sort of the beauty of how USD works. And yes, this is super technical, but hopefully you can see how that could be really beneficial for, if you're creating a bunch of different shots, you could create a bunch of different layouts, you could create, different shaders for different shots, things like that, and have those all, saved and used in some sort of sublayering setup or different ways to set up your node hierarchy. So it's a really powerful way of working, I think, and I think the industry sees that as well and is starting to really move towards this. So that is all, kind of, it's very detail oriented, right? But I think there's a lot of information there that can really benefit you as you're going through and looking at it, and to not be afraid to kind of look and see what's going on inside of these files. I think it's a lot simpler than you might think of at face value. Especially if you have something like this that highlights your syntax for you, it makes it a lot easier to look at. So we have those different files. Now, remember I was saying here with this duplicate node, we could, yep. So what we're doing here, if you remember, as I was looking through that, I said it's making a reference. Now we could also do something like make a copy. And so this is going to be a little bit different in the way that it works. In fact, that's interesting. It doesn't look like that's working the same way. Let me just see. Maybe it can't do that with the mesh. Let me just see if I can do it this way. Yeah, it doesn't seem to like that. It's really odd to me. Not sure why that's happening. Oops. All right. Well, it might be because of the shader or the way I'm doing this possibly. Let me just try something real quick. Sorry. Let me do this and this. There we go. Okay. So the reason that wasn't working is because there's these layer breaks and stuff like that. So it really can't copy it because it needs to reference it because it's coming from a separate file. So it can't just copy that. So that's why that's happening. Anyways, not a huge deal. We're just gonna forget I was even gonna go down that road. But let's talk about how to clean this up a little bit, right? Because we've got these two nodes here and it just seems kind of a little bit like a mess. Seems kind of a silly way to work. So let's do this instead. Let's get rid of these. And let's get rid of these. And instead, let's do a layer, configure layer. And this is really the workhorse. And I think the way to go most of the time here. Now, let's see. So what we're going to do first is we're going to set a save path here. And I'm just going to write over these files. So we're say geo.usd. And so now we have a save path set here. If we scroll down, we can see that we can start a new layer after this. And so now we're starting a new layer. Another thing to keep in mind is that visually, the color here just changed because now it knows that these are in a new layer. So these halos are telling you when new layers are starting. So something that's not super obvious to start with, but that's going to start giving you that hint. So, okay, so now we're down to this configure layer 2. In fact, I'm going to call this geo. And instead of this, I'm just going to do $OS so that I'm just going to make this a little cleaner. Sorry. So we'll make this, and instead of geo, we'll call this MTL. And instead of that, we'll call this one layout. And so unfortunately, some of these colors are very similar, but you can sort of see that those are different, hopefully on the stream. Okay, so we're starting new layers at each of these. And there's some other things we could do too. We could flatten the entire input stage before it, so we could just flatten everything into one file. It's not super helpful, especially in this case. But if you needed to at some point, if you needed to make sure everything was saved in one file and there wasn't anything, kind of being loaded by references and things like that, you could certainly do that. But now, if we look at this here now and look at our scene graph layers, we can see, I'm going to slide this over. We can see that our save paths are set, and we have these explicit save controls made. So we know that this first layer is going to be saved to geo, this second layer is going to be saved to material.usd, and the last one's going to be saved to layout. And then what I'm going to do at the very end is I'm going to make a USD ROP again, and I'm just going to call this scene master, just like that, whatever. Not a huge deal, but we're just going to say USD assets, and then I'm just going to put OS here. Okay, so that's going to resolve to scene master. And the really cool thing with this now is that this one ROP is going to run everything up the chain here. So everything up the chain here is going to all save at the same time. And just to prove that, I'm just going to delete all these off the disk. Oh, you know what? It's not happy with me because it's reading those in here. So I am going to if I do this, let me just see if that will do it. Let me delete them. Yeah, that's okay. We'll see that this all gets written out again because the times will change. So let's just do this. We'll save it to disk. Oh, put in the wrong folder. Okay, let's try that again. But we can see that those all changed. So let's hit save again. We'll have a scene master next to this, and all of these are now updated as well. So that all were saved at 926. So now what we could do is, in fact, let's do this. Let's do this as a USDA. And let's look at that, so we can see what this does. So this is the simplest file possible for USD, right? So you can see right here that you have 3 sublayers that are all defined in this file, and that's it. So it's loading, and it's going from like top to bottom with the layers, right? So it's loading geo here, then it's loading material, then it's loading layout on top. So it's geo, then it's laying material on top, and then the layout on top of it. So it's a super simple file. And now if we take this and sublayer just that one file, we will see, let me open this back up, that everything came right back in. And there we go. I changed this around a little bit the way it's working, but not a huge deal there. So we can do that. Now we could also still do this, and this should look exactly the same, right? So if we selected all these and just reloaded them to make sure that they were all loading in the right way, sure enough, they're all working. So this is some of the interesting parts of working with USD. And if we look here at our layers now, we can see that the layer names are actually the paths on disk, and save control is saying don't save. You don't have to save anything. So if you put like a USD ROP down here, nothing's going to get saved on disk. It's just going to say, it's going to look exactly the same as the way this does right here, where this is loading all those on disk, right? Because if you look here, this file is basically saying scene master, and then these are the names of the other files that are loaded on disk. These are those sublayers that we saw in that text file. So there's some really interesting, details going on there. And yeah, this stuff is all really technical, but I think that if you're in the process of building, scenes and layout and things like that, these things can be really, really beneficial to be able to understand USD and work with it, better. And so hopefully that's all making sense. Hopefully you've stuck with me this far. I know it's a little bit, we're looking at file data and stuff like that, ASCII files and things like that. But hopefully you're sticking with me and we're able to kind of understand this and make some sense of this. So if there's any questions or thoughts, I'd love to be able to answer them and kind of talk about them. Hopefully this is starting to give you some ideas for how this process might work when you're dealing with this in larger scenes or setting up, whatever, any size scenes. I know quite a few schools are starting to build, even students are using this to build up pipelines for themselves to work with each other. And so it's great for collaboration. It's great for even just building stuff for yourself and keeping, things separate, right? You can keep all of your scene assets, right? And then create different layouts for different scenes just in separate files. You could make branches and save out your different scenes, save out your different branches. There's so many different ways that you could work with this, and create workflows, even just as one artist working. You could do a lot of stuff with it. So I think it's a really flexible thing to be able to work with. All right. So if you guys have any questions, please drop them in the chat. Also, if you are interested, you can go to HoudiniHangout.com. There's information about the upcoming stream times. There's also information about or a link to Discord. So if you want to join on Discord, a lot of people, it's starting to be a little bit more active, which is great. Having some good questions in there. I know that some different people that are really very knowledgeable have started helping people out with questions in there and stuff like that, and when they put their comments in there. So it's can be a really great place to just be able to chat, learn. Also a place to post ideas for upcoming stream topics and things like that. I'm going to be, if you look at the schedule, I'm actually going to be gone for a couple of weeks on vacation. So there's going to be some it's going to be kind of a little gap of time here with it coming up at the end of the month. But I'm thinking of a few things that are going to be interesting to be able to kind of kick back in March and April. So I know in March I'm also going to be in San Francisco for GDC. So that should be fun for me, but of course I'll also be out for that week as well. So a little bit of travel this year, a little more than last year, but hopefully we'll be able to get a lot of good streams in still. So, all right. So I have a couple more things I wanted to talk about, and if you guys have any more thoughts or questions, we can always chat about whatever. So, all right. So, I was going to talk about the merge lop. I guess all I'm going to say, no, I think I can do this. All right, we'll do this kind of quick. I'm not gonna take too much time on this, but I just want to make a point to say that the merge lop in Solaris or in lops works way differently than it works in SOPs. So let's take a look at that. Let me just name this real quick. Okay. So what I'm going to do, I'm going to make a primitive, and I'm just going to name it, kind of give it some basic naming. And what I'm going to do here, let me see here. Where did I put that? Over here. So if you, excuse me, wow, that was a yawn. So I'm going to create this setup right here. And you'll see in a second how this works. Hopefully it'll make sense. But this is what I'm going to make here. So I'm going to make 9 different primitives, and I'm going to turn them all into their own layers by using this little debug flag. So now it's going to be its own layer. So here you can see it says lop layer stage A. That's what we want. And then I'm going to come down here and say B. So if that's not on, it's just going to keep going in the same layer. If this is on, it's going to create its own layer. So we've talked about layers, so hopefully this is going to make some sense. And I'm just going to name these real quick. So we're going to do A, B, C. Then we're going to move over here and do D, E, F. And then we're going to come over here and do G, H. I said H and typed G again. GHI. Okay, great. So that should A, B, C, D, E, F, G, H, I. Great. And if we look down here, we're going to see we have G, H, I like that, right? And if we do a merge, let's take a look at what happens here. Okay, so we have A, B, C, D, E, F, G, H, I. So they're all, everything's good. However, when we look at this here, so it's merged everything together, but it's also merged everything, all the layers together, and it's in one layer, just I. And let's take a look here. And so there's these different modes that we can do this in. So let's do separate layers. And so now we can see that all of these layers are going to be separate, right? So if we were bringing in a bunch of files on disk, aka layers, and we brought them in here through a merge node, it would actually flatten them all together if you didn't have this in the separate layers. If you had it in the simple merge mode, it's going to just go into this last layer here, which is I. So if we look at this and say, it's going to just name them all I, right? If it's flattening it. So if we do a simple merge or flatten layers, that should be exactly the same. So that's what we're looking at here. So we have separate layers, flatten layers. We can also flatten into the first input, which sounds like it's saying flatten into this path here. But what it means is flatten into the first layer, which is going to be C, I believe. Or it's A, sorry, A. So we're going to say that. We're going to say flatten into first input layer. And there we go. So now we have A and B separate, right? We have A and B separate, but everything else has been flattened into this one layer. So these are all flattened into one layer. So again, if you're bringing, creating separate layers and trying to work with separate parts of your network, and you're creating these different files that are going to get layered on disk, and then you put a merge down, it could do some really crazy things that you're not expecting it to do. So this is a thing that you just need to be aware of, right? And understand that there's some different methods here. Another thing you can do is flatten each input, which is kind of interesting, right? So each of these inputs are going to be flattened together, which could be beneficial, right? You might want each of those like kind of different inputs to be their own, saved to their own file on disk, right? So again, a little bit of a, strange way of working, but, there could be a reason that you would want to flatten them all into one file to be saved to disk, later. And if we look here, we're going to see that obviously the save controls and things like that are going to go along with those. And so whatever you have a save control set would work. So like if we were doing this, let's say instead we did a configure layer here instead of a primitive, and just called this one C, and set a save path just to USD and said c.usd, and made sure we have a new layer. Right, because these are, yeah. Let me see. Sorry. Let's just take 1 second. So it should still be C. Let me just see if this works. B. I have not tried this before, but let's see if it works. Hey, Andrew. Yeah, I'm doing good, doing great. Thanks for being on the stream today. Okay, so here we go. Now it's working. So if we come down here to this merge, we can see that C, everything in that one chain is all saved into this C file, right? So if we had a bunch of different configure layers up here, maybe doing multiple different things, they would all get crammed into that one stage C here. Now we don't have primitives in our scene graph tree, but hopefully you can see how that would work in that scenario. So this is just something to keep in mind. And this merge lop on the documentation is super helpful to understand how this works. So if you are doing that, just keep that in mind. There is another there's another option that you can do called graphed branch. Oh, smacked my mouse. So what we could do here, we could use this graphed branches, and this is kind of, it's different. It's different the way it works. So basically what this does is we can take a source primitive and a destination primitive here, right? And set those up. So for our source primitive path, we could set all of those. And then our destination primitive path, we could set that as, no, we could just set that as such. So there's our source primitives, right? And then we could set this here to be under D, let's just say. And so what this can do is basically take one branch of your tree and another. So this is almost like using a reference, but for sections of your network that are in memory and haven't been saved to disk. So it's kind of a way to be able to reorganize just a chunk of your scene. So it almost is like the way you can select a part of a file to reference and then put it wherever you want in your scene graph tree. It's kind of the same thing with graphed branches. So that's something to keep in mind. And then there's also graphed stages, which I think is similar. Yeah, I think this is just going to bring multiple stages together. Let's see here. Yeah, so this is going to yep. So what we could do here is we could say, yeah, so this is just taking the input, which is F, and using that as the path default. But you could set this to whatever. You could probably set this to /D. And that would change it like so. Let me just see here. Oh, I see. This is where we want it, like that. So this we could just set like that. Yep, there you go. And this would be basically the same thing, except you could graft multiple together, at the same time. So yeah, so those are just a little bit different ways of thinking about working with stuff. But this merge, just a good thing to know that it's kind of different. It's not, doesn't work the way that you would expect a normal merge to work. So I'm just gonna type in merge here. There we go. Cool. All right. So the last thing I think we'll talk about today. We've talked about the instancer a little bit. Let's just look at that maybe real quick, and then we can look at animation. So we'll do another quick little section here. So let's just let's do a reference here, because we're going to reference in a few objects. So we're going to say ref prototypes, like that. And what we're going to do here is we're going to bring in some of these elements that we did earlier. So let's grab our tree asset. Sure. We're going to grab a couple of them. So let's grab our toy. Oh, that's right. We don't want that. Let's just grab the geo of it. That's fine. And then let's grab this flexible soup cans here. Cool. So we have all of those different prototypes. So we've got those set up there. The other thing I want to do is I need to set these as a different primitive path. So what I'm going to do is just say, we'll just say source like that. So we'll add a source primitive above it just to kind of group them all together like that. So now there's source and they're all grouped inside of that. So let's do an instancer. And here you can see we have our prototype sources and our input stage. We don't need anything for the input stage because there's nothing on the stage right now. So let's do that. And in here, we're just going to do a grid. And then let's do a scatter. Probably too many. Let's do like 100 just to make it a little less, right? So there we go. So now we've got a bunch of scattered objects in our scene. So what I'm going to do is just make sure. So let's just say you had something else going on in here. This is basically just going to say, take the last, take the last modified primitives. So instead of that, what we're going to do is we're going to control click here and we'll just say source. We'll just get that and then say slash and then star here. So we're going to get one of each of those in that, scenario. So, okay. So we've got our prototype primitives here. We could set our target points from a few different places, from an internal SOP, an external SOP, or we could use the points or primitives from the first input. We're just going to use the internal SOP for this for right now. So that's good. And yeah, that's great. All looking good. So the other thing that we can do here is we can see that this instancer has a couple different, has really just this one section here called prototypes. And prototypes is basically just a way of saying those are the primitives that it's going to look at, that it's going to use to copy to this, to these points, right? So each of these under source are going to be the ones that it copies onto the instanced points. And the instancer is what holds all of the different positions. For example, if we look at this and look at positions, we can see that there are 100 positions, or 99, index 99, which is all of the points that are inside. So this instancer primitive holds all of the positions, all of the orientations, the indices for which prototype goes to each one. So this one is 0, this one's 2, 1, blah, blah, blah. So they're all random, right? So that's where all those pieces of information are held, right? That's in the method of point instancer. If we change this to something like instanceable reference, now you can see that there is a specific primitive for each and every source that came in, each prototype, all the way up to 99. And they are blue because they are instanceable. What instanceable means is they're kind of like a packed primitive kind of version in USD. And so what that's going to allow you to do is really efficiently in memory, only load those 3 primitives, in total once, and then use a really simple reference to just say, okay, each of these are just pull them from memory and do it like that. Like it's a really simple and memory efficient way of like taking from those prototypes and kind of copying them around basically, right? So that is the instanceable reference. However, you could also do just a regular reference. And what that's going to do is do something sort of similar. Oh, that didn't like that. Let me just make sure I'm saved. It's going to do something sort of similar, except that the instanceable flag won't be set on those. So each of those, these primitives are going to have to go and reference that file from disk, right? It's going to specifically reference each of the time from disk. And there's benefit to that because an instanceable reference, you can't actually, when you have them all like this, you can't go inside and set anything in here. Like you can't set, like override a shader on it. It won't let you do that because that is not part of it. So for instance, let's see if we can select one of these here. Let's just do, which one is this? just going to find one of these cans here if I can. Okay, so that's one of the cans here, 70. I'm not sure which one this is. Let's see. It's that one right there. Cool. Okay, so it's that can right there. If we hide it, we can see it right there. Okay, so let's just say I wanted to change the shader. The shader is set right here on this can, right? Let's do the label. So if I did a material library and made, let's just do a principled shader, and we'll make it something obvious, maybe gold. Okay, then we do an assign material, and we're going to take the material path gold. I'm not doing this well, I'm just kind of doing it quickly. And then we're going to take this right here. We're going to set this to the label. Boom. And we get an error. What it says right here under the warning is cannot create a primitive spec at path, whatever. Authoring to an instance proxy is not allowed. So if you have something that's instanced in USD, you cannot write anything inside of here. That's kind of why these are all purple like this. It's kind of to tell you, hey, you can't write anything in here. Now you could, if we turn this off and did the same thing for instance 70, let's do set variant. We could change the variant for this. That is possible. So that's instance 70. Okay. Because, so let's take the variant set label material and we'll change it to peas. So now we have a green label there, right? So we've canned peas. Now the reason we can do that is because that variant information sits on this top level, right? So here's our variants right there. And we change it to peas. So that lives at that very, very top level. So when you make a good USD asset where your variant information lives at the very top level of it, you're in luck. But if you need to go inside and change your shaders and things like that, you cannot do that when they're instanceable. So in this case, what we could do is set this to be a reference, right? Build our material library and go to our assigned material here and hold on. Maybe what I will do instead is I will do this. There we go. That's why, because I was doing the proxy one. Sorry. Let me do this. I'll do the label like that and change it. So that's something to keep in mind. If you changed it just on one, you wouldn't see it per se. So let's do this, and I'm just going to render it with Karma real quick, and you should see that, yep, it's now gold. So because we set it to reference, we're able to go inside of here. But the second you set it to instanceable reference, it says, nope, we can't go in and change that because we're doing things more efficiently and we can't change any of that information inside. So just something to keep in mind when you're doing instancer stuff. And that's why you cannot do that. I'm going to take these off. Just leave that the way it is. Go back to GL. Okay, so one other thing to kind of keep in mind is that you can actually adjust the prototype index by an index attribute here, right? So it's probably going to set these all to the same one. Not happy with me. Hold on. There we go. Okay. So the problem was it was just going all to index 0, basically. Okay. So what we're going to do instead is we can come inside of here and we can set, Oh, okay. Didn't like that. Bummer. Let's reload. Sometimes that'll happen to you. There we go. All right. Cool. Pretty much right where we were. Instanceable reference. Cool. Okay. Interesting. You know what I think might have actually might have been? I think it was freaking out because it might have been in reference still. And it takes a lot longer to load that all up. Yep. That's what it was. Instanceable reference, much happier. Anyways, it's going to say, hey, there's no index found. So we're going to go in and change that. So what we can do is we can do on attribute adjust integer. We can set this to index. And now when we change this, you're going to see that they're all going to change, right? So we can also maybe set this a little lower, maybe like 50, because give them a little more room. Cool. So there's all of our flips. And so as we change this index, we can see that it's going to change which source primitive we're bringing in, right? We have our prototypes, and we're selecting from these three, right? So now you can imagine that if we did a noise attribute here and did the minimum as 0 and 2, we could do that and kind of creates a noisy attribute for it. We could also, if we did more, like maybe something like that, and then also think if we did a float, will this work? I can't remember if it sees p scale or not. Yep, it does. Great. So we'll just scale them down like that. We'll use p scale to scale them down a bit. So this really works very similarly to how copy to points works. It's just the USD version of it. So if we take this and now adjust our element size here, right? So we could make it bigger, and the noise is going to get bigger like that, or we could make it smaller, make it more random, however we wanted to do it like that. So we could also remap to have more of one versus the other, kind of push these around to remap our values, all that kind of stuff. So this is how we can actually set our which ones that we're kind of sourcing into our scene. We can have a lot more control over it this way than it just being completely random. You can do that from an index attribute. You can do it from a name attribute. You can do it from a path attribute. So there's a lot of flexibility there, and that's kind of how the instancer works, and is obviously very helpful for scattering objects and things like that in a scene. So yeah, so that's the instancer, kind of in a nutshell, quick little touch on it. So yeah, if you have any questions about that or think I missed something or whatever, I'd love to hear it. Drop it in the chat, and we'll talk about any questions or thoughts or anything like that. I mean, obviously there's a lot to all of these things. I can't really get into every single detail of them, but just trying to give you a sense of how to work with things in USD and in Solaris. Cool. So the last thing we're going to talk about is animation and how does that work. So let's do this. Let's work with some of the things that we've done already here. So let's do this. Let's bring this in. All right. So we're going to bring this down here. All right, down here. All right, so we're going to bring our tree asset in, the whole scene. And let's do a... Actually, you know what? Sorry. My apologies. I'm going to bring this in just like this and use this. So, and then we'll say anim tree geo. And here, I'm just going to call this, yeah, that's fine. Cool. All right, so we've got these things that were created. They're not on disk yet, right? So these things haven't been written to disk. But what we can do, and something really interesting actually about the SOP create, is there's actually a layer save path right here that we can set up. So I'm going to put this under USD anim, and we're going to say geo.usd. Okay, so it's going to go under that section right there. So that's our layer save path. And in fact, we should be able to come over to our scene graph layers and check out that sure enough, we have this geometry set explicitly. Our hierarchy up here is set up. We could take that out. It actually probably doesn't even really matter that much. Yeah, it's basically the same thing. So we'll just start like this. This is our animated tree geo. Great. So we have one layer there. So then let's just say we wanted this tree to move back and forth, right? So let's do a SOP modify here. So let's just say you had, a model that was coming from disk or from somewhere else, whatever. So we've already got our geometry set here, and we can save that out. However, what we could do is we could do a SOP modify right here. And let's see, we're going to select from our primitives here. We're just going to say tree. And if we go inside of here, oh, let me just, okay, there we go. I was like, why is that coming in? It isn't. All right, so we have successfully just brought in the tree geometry. And so what I checked here, you can actually unpack it. So we can come inside, and right now it's 3 packed USDs, right? So we probably don't want that. Let's instead, we'll just unpack the geometry, and that should be good. Doesn't really matter for that. Sorry, I thought it wasn't doing it properly, so I was selecting some things. All right, so there we go. Now we have unpacked geometry here, and we could do something like, let's just do a bend, right? And we will set the capture region. What? That's fine, whatever. So capture origin, capture direction is going to be 1, like this. Capture length, we'll just adjust that a little bit. Cool. And then what we'll do is we'll have the bend and we'll just animate it swinging back and forth. So let's just do a sine of $t, I guess. Let's try that. And then we'll multiply that times 20. I don't know. Nope. I see. Let's do that, and we'll do... That's just going to make it go faster. Maybe we'll do $F. There we go. So there's our tree animating back and forth. It's going to get output, and it should come back up here. Yep, sure enough. We're animating it. Cool. So let's look at our scene graph details here. So we have these extents animating. These have a different color now. So if we look at our points, these are time sampled. So it's kind of interesting. They're going to be animated now. They're time sampled. So it's cool. So that's all good. We'll just say tree anim. And then if we wanted to, let's just look here. So we're getting pretty good playback, right? We can play back real time here. We can lock that down to real time playback. It's all looking good. Great. So let's do a layer, configure layer. So we'll save our animation here. So we'll give this the same save path, except we'll call it anim. Okay, so we've got that. That's being saved, and we're going to start a new layer. So now we have our 2 layers saved, and we're going to do a USD ROP. And then this will be, we'll just call this anim tree scene. We'll just change this to $OS, and that'll be anim tree scene. Great. Okay, so here we need to change some things, right? So let's go from render current frame to render specific frame range. There it is. So, okay, that's all well and good. But let's hit save here, see what happens. Okay, cool. So let's go up, go into our animation folder here. All right, well, it's kind of interesting. We only have one USD file for our animation, right? That's kind of weird. In fact, you know what? Sorry, I'm going to get rid of this configure layer because that's kind of could be messing us up here. So let's try this again. So instead of just doing 2 separate ones, we'll have one that's the tree geo, and then we'll have one that's our animation scene. So let me just do this. I'll get rid of our anim USD. No reason for that. All right. So now we're probably expecting there to be a bunch of files, right? A bunch of different files. So let's do this and see what happens, right? We have all these frames that are getting saved, but no, we don't have a bunch of different files. We just have one. Kind of interesting, right? So you might then think, okay, well, what if we did this? Flush data after each frame. That's kind of interesting. What if we did that? Or let's do this. Let's do, we forgot our $ F. We'll do F3. Well, that didn't do anything. Just made one file again. That's super strange, right? That doesn't make any sense. Okay, get rid of that. All right, so now let's do the flush data after each frame. Save that out. Okay, so now we have our individual frames. It's weird that it didn't get $OS. Oh, maybe it's because of this. Maybe it needs to be like that. There it is. It needs to be a period. That's so funny. I never really realized that. Anyways, let's just get rid of these. Redo it. Only take a second. All right, let's save it to disk. Okay, cool. Now we have that saved properly. Great. We have all our frames out. Great. Looking good. So let's just remember, we've got this at 24 frames a second. Can speed it up to about 40 frames a second, right? So now, okay, cool. That sounds good. Let's sublayer that back in and double check it. So we'll bring in our $F3 here. Great. There it is. So let's play that back. That's actually not doing too bad. Let's just do something here, just for kicks. Just want to create some more geo here because it might be a little too light for this to actually work properly. Let's try that. All right, let's try this again. Sublayer it in. Well, apparently I've made the one option that actually works in this case, which is funny. Okay, let me try one more thing here because this shouldn't actually work this well. Of course, it works better than I'm expecting for it to. All right, let's do this and let's grab that tree in there. And what I'm going to do is do the same thing with, I'm just going to have it rotate. Yep, I'll have it rotate as well. See how this works. We'll do $F. Maybe that times 5. Yeah, let's try that. See how that works. Not sure if that's going to be any different, but we'll give it a shot. Well, what should happen is this shouldn't play back at a high speed. I've done this with a bunch of other things and it's worked terribly. I don't know why this is working so well. But what you should do, which I don't know why this is working, is you should, instead of trying to do the normal Houdini thing here with the $F3, you should, you should take this out, just like that, not flush. Now, there is times where you need to flush the data after each frame. Usually that's for really big simulations that can't save all the data to one file. But here, so we're going to hit save now. This will do the same thing, but it'll save it all into just this one animation tree scene. So we'll load that in. And this, okay, so there we go. So while the other version was playing back really fast, you can see that this is hitting almost 120 frames a second, right? Whereas if I go back to this one and play it, the fastest it can go is 40. So there's quite a bit of speed difference between those two when they play back. And the more that you have going on in your scene, the more that you're going to notice that. So your best bet is to save everything as one file with USD. It actually likes to have everything in one file. That's its best option. If you do have a really big scene that now sometimes the problem is that you need to save everything in your scene to one file, right? So it has to take all the data from every single frame and then put it into one file. And if you're doing a huge simulation that's a gig a frame, you can imagine that you'd run out of memory when you do that. So in that case, doing it single frame is really the only way you're able to get it to work. However, there's some other, kind of special cases that you can use to help stitch those clips together after it at the end. One of them is called USD stitch clips. So if you want to do that, where you can efficiently take your a big simulation or something like that and have just one file that references all the other ones that are on disk and makes it more efficient for USD to work with, USD stitch clips. It's a ROP. And you can run that and it'll actually do a little process and create some files for you that'll work. And there's some really good documentation in the documentation about that. So I'm not going to go into that here because that's super technical and way deeper than we need to go. But really the thing to say here is just that you want to save everything as one file where everything can live in the same USD file. So hopefully that makes sense. And you can see that there was a speed up of a slowdown of about 3 times when going from using $F3 to just a single file for all of our USD. So hopefully that is clear here. And I'm sure you're going to probably run into that at other times while you're working with USD. So just something to know while you're, saving files and things like that. So, but anyways, that is where we are going to leave off the stream for this evening. I hope this was interesting for you, and hopefully this was, some interesting information, at least to be able to understand some more about what USD is and how it works. And I know that there's a lot out there as far as working with tools and Solaris and things like that. So I don't want to focus on that so much. I want to really focus more on what's going on with USD, because it can be really confusing if you're trying to use it, but you don't really know where to start. This hopefully can be a good way to kind of dip your toe in and get an idea for what's going on actually under the hood. So that's it for tonight. Thanks again for joining. And I will be streaming next Wednesday and then have quite a bit of a break after that for some vacation for me. So really appreciate you all being here tonight, and I'll talk to you next time. Thanks, everybody. Bye.